Good morning, and welcome to this discussion on numerical from free-falling bodies. Now, this numerical is essentially a body has been thrown upwards, and then it goes up, traverses the vertical distance, and comes back to the original position. So, if you have to classify the motion, this is a highly symmetric motion, and it will follow all the symmetricities which we understood as a concept. Now, what's so special about this numerical is the fact that there is a particular position above the ground, through which the body goes up, and then when it comes down, it again passes through the same point. For example, you are, at the window, and suddenly a stone passes the window, and then stone comes back to the window, and the window is located, at a distance of 5 meters above the ground. Now the time elapsed between the first time you saw the body and then when the body came down the second time, the time elapsed is 10 seconds. If we use the concept of symmetricity, the symmetrical part of the motion, then t upward should be equal to t downwards. That is first part, which means the upward part is 5 seconds and the downward part is also 5 seconds. Use this knowledge that your displacement at point A is 5 and calculate the initial velocity of at the point A, which comes out to be 50 meters per second. Now, since you know the velocity at point A and highest position, the velocity is 0, so you could calculate the initial velocity at the point A. Now use this another concept of symmetricity, which is if the body is coming down at the same height, when it appears at the second time but this time downward, again the velocity will be 50 but in the reverse direction, right? So second time we are using the concept of symmetric motion. And third, remember the body is thrown with some velocity and the body will come back with the same velocity. So when you're analyzing the velocity at the ground, it will be same as the velocity with which the body was projected. So do this in the following sequence. Number one, use the principle of symmetricity at point A and A dash 5 seconds each. Calculate the velocity at A. Use that velocity at A to calculate the ground velocity. Again apply the principle of symmetricity, saying whatever is a ground velocity upward direction will be the velocity in the downward direction. And then use the fact that total time is twice the time taken to traverse one side. So you see the downward part, the calculations there. In the end I have multiplied the time with 2 seconds. So slow down the video, stop the video, look into the principle of symmetricity applied at UA, then U ground, and then finally in the downward motion everything has been consolidated. Thank you very much.